Here I am going to explain the astable multivibrator using 555 timer. Here you can see the circuit diagram externally connected to the 555 timer to work as a stable multivibrator, and here you can see along with it the internal diagram of the 555 timer, so you can understand it better. You know that pin 2 is the trigger pin, pin 6 is the threshold pin, and pin 7 is the discharge pin. So with the explaining the normal working of a 555 timer, you know that when pin 2 goes below 1/3 VCC, the output is high. That is, the output means the output at pin 3 will be high. And when the threshold pin, that is a pin 6, goes above 2/3 VCC, the output at pin 3 will be low. So here, when the power supply is on, the capacitor tends to charge towards VCC. But when the charge reaches 2/3 VCC, the output goes low. The output is low means the input of the inverter is high. When at this point is high means the Q1 transistor is on. Q1 is on indicates that the capacitor has a path connected to the ground. That is, the capacitor can discharge through this path. That is, the capacitor can discharge through RB, through Q1 to the ground. So, that is, the capacitor on reaching 2/3 VCC, it discharges to the ground. On discharging, as soon as it reaches 1/3 VCC, the output will become high. The output is high means at here, this point, the input of the inverter is low. That means the transistor is off. That is, the discharging path of the capacitor. The discharging path of the capacitor is cut off. Therefore, the capacitor stops discharging and will again charge through RA, RB to VCC. That is, on reaching 2/3 VCC, again it will start discharging. That is the graph shown here. And with respect to this, we will get a square waveform at the output. This output is at pin 3. This is the working of 555 timer in a stable configuration. So the charging time constant here is RA plus RB into C, and the discharging time is RB into C, because RA plus RB into C indicates that the charging takes place through RA and RB, and during the discharging only RB takes part. So this is all about the stable multivibrator using 555 working. This is the detailed waveform showing the capacitor charging and discharging and the output at pin 3. You can see the time taken for charging, the output is high, and during the discharging time the output is low. So this is the equation for the capacitor RC low pass filter, and here we are going to put VC, that is a charging and discharging of the capacitors 2/3 VCC and 1/3 VCC. We are going to put it here, and we are going to find T1 and T2. T1 is the time taken to charge the capacitor from 0 to VCC, 2/3 VCC, and T2 is the time taken for the capacitor to charge from 0 to 1/3 VCC. So we can find that the time taken to charge from 0 to 2/3 VCC is 1.098 RC, and the time taken for the capacitor to charge from 0 to 1/3 VCC is 0.405 RC. Therefore, we need to find the charging time from 1/3 VCC to 2/3 VCC. Therefore, we subtract these two times to get 0.693 RC, where R for charging is RA plus RB. Therefore, the T on is 0.693 RA plus RB. That is, the charging time is the on time. That is the time at which the output is high is called as the T on. Therefore, it is given by 0.693 RA plus RB into C. And here we can see that Off time means the discharging time of the capacitor. During the discharging time, our resistor which take part is RB, that is 0.693 RB into C. So taking into account the T on and T off both, that is the total time period of the waveform is T is equal to 0.693 RA plus 2 RB into C. That is both T on and T off. So from this we can know the frequency is 1 by T, that is 1.45 into R divided by RA plus 2 RB into C. That is 1.45 is 1 by 0.693. That is 1.45. So coming to the duty cycle. Duty cycle means on time by on time plus off time. That is duty cycle. Here we see T on by T into 100. That is, from this we will get RA plus RB by RA plus 2 RB into 100. This is a graph showing the RA, RB and RC combination for different frequencies. That is, the astable multivibrator output for varying capacitor values, how you can vary the RA and RB values. Here we have got a question. Determine the frequency of oscillation in duty cycle if the duty cycle D is equal to 20% and the on time T1 is 1 millisecond. So we are putting duty cycle, that is 20% means 20 by 100. We have got T on in the question, that is 1 millisecond. Therefore we have to find the frequency of oscillation. Frequency means 1 by time period. So we have to find the time period. T on plus T off, we will get it as 5 millisecond, and its reciprocal will give the frequency, that is 200 Hertz. Here we have got another question. To design the astable multivibrator, similarly you have to put in these equations these particular values given in the question, and you will be getting the answer. So finally you can find RA and RB from this equation. So next we are moving on to the applications of astable multivibrator. The applications of astable multivibrator are FSK generator, pulse position modulator and Schmitt trigger. This is the FSK generator. That is, here we can see an additional QM and an RC connected here, right? Other than that of the normal astable working, we have got a QM and RC. Here, and also we can see an input digital data. When the input digital data is high, QM is off. You can see QM is a PNP transistor. Therefore, when the base is given high, the QM will be off. Therefore, when input digital data is high, QM is off. Then the circuit will work as a normal astable multivibrator, and its frequency is given by F1 is equal to 1.45 RA plus 2 RB into C. That is a normal frequency of an astable multivibrator. So again, when the input digital data goes low, the QM will be on and the effective resistance will become RA parallel RC in series with the resistance RB. Therefore, the effective frequency will become 1.45 by RA parallel RC plus 2 RB into C. And at this time, the output frequency will vary. Therefore, you will be having two frequencies at the output. That is, when the input is high, the output frequency will be this, and when the input is low, the output frequency will be this. The input means the input digital data. So we can vary the frequency at the output. That is frequency shift keying generator. So we will be having two frequencies at the output according to the input digital data. As it goes high and low, we will get F1 and F2 frequencies combined, a combination of F1 and frequencies at the output. That's all about FSK generator. And this is a problem of teletypewriter using frequencies. So this is the design of FSK generator. Just go through it. And here we have got a pulse position modulator. Pulse position modulator means here the position of the pulse is varied at the output. You can see the pulse position is varied at the output. Here a modulating signal is given at control pin 5. That is, the modulating signal is applied to the modulating control pin, and this changes the threshold voltage condition for the upper comparator. Therefore, the output pulse position varies due to the modulating signal. Therefore, the output waveform obtained for an input triangular waveform gets a modulating signal. Next we have got a Schmidt trigger. In this, the pin 2 and 6 are shorted and a VI is given at this position. So the voltage, when it goes below 1 by 3 VCC, the output goes low, and when the V goes above 2 by 3 VCC, the output changes. Above 2 by 3 VCC, the output goes above 2 by 3 VCC, the output goes low, and below 1 by 3 VCC, the output goes high. This is the output and this is the input. Okay, this is all about the applications of astable multivibrator.